All right. So in the last class we okay, welcome to class everyone. In the last class we looked at binary operation. We finished everything on binary operation. We solved questions on that. And today we'll be looking at a very interesting topic which we call the circle theorems, right? So now for us to understand the circle theorems, we need to understand what a circle, the different parts of a circle, right? Because different part of a circle is going to help us to actually understand um, how those theories work and how to apply them, right? So now the key thing about a circle is when you have a circle like this, any line that you draw from the edge of the circumference to another end of the circumference is known as a chord. So any line that runs from one point on the circumference, another point of the other side of the circumference is what we regard as the what? As the chord, right? Now, a chord that now divides the line into two is now regarded as what? As diameter. That is why sometimes you start hearing that all diameters are chord, but not all chords are diameter. You start hearing things like that. So a line, a chord that divides the circle into two is now what we regard as your what? As your diameter. But at every point in time, it is important to understand or to remember, as the case might be, that what? This is your diameter. So when you run a line from one point of the circle to another point, that line is regarded as the what? As the chord. And the chord, we divide the circle into two parts. It's going to divide it into what we call the major segment and the minor segment. All right, sorry about that. And when we talk about the minor segment, we talk about the down part of the circle, as you can see on the screen, right? That is your minor segment. So this portion is your minor segment, while this is your major segment. So at every point in time, the chord, which is a line that runs from one point of the circumference to another point of the circumference, is your what? Your chord. And I said I divide the circle into the major segment and the minor segment, which means for a diameter, all the segments are equal, right? The major segment, we don't have anything like major and minor when it comes to the diameter because it divides it into two equal parts. All right, that said, we can now move into the theorems or the circle theorems under your geometry. I will talk about seven theorems, but in your textbook can be more than that. But I've summarized all the theorem into seven key theorems you need to remember for your UTME exams. Remember that this is just the circumference of a circle, right? More like the perimeter. The perimeter of a circle is what we call the circumference, what is bounding the circle. All right, let's look at the very first theorem. The very first theorem says that angles in the same segment are equal. I've actually established that there's a major segment and there is a minor segment. So once they are in the same segment, the angles there are going to be equal. So the first thing you must check out for is your chord. So once you have a chord, you check this is a chord, then this is your minor segment, this is the minor, and then this is the major. You could see that from this same chord, an angle was formed right here. From that same chord, another angle was formed. So angles in the same segment are equal, right? And then I made a statement. They are in the same segment and they come from the same word chord. This is very important. So aside the fact that they are in the same segment, they should as well come from the same chord. If I'm to resketch this diagram so you could understand what I'm saying better, is that when you have a circle this way, now, let me do it downwards. The one I drew here was facing upwards. Let's make it face down. So this is a chord. Now, when you have this chord, there's a line that will be formed from this same chord. Let's say that we'll have this line running through from here, right? An angle is formed. You remember an angle is formed when two lines meet. So we have a chord formed right here. Sorry, an angle formed right here. Are you there now? So from this same chord, we have another angle. Let's run through another angle from that same point. So from here, we have an angle running through this way to this point. Now, and the next one, still from the same chord. So you could see something unique. This angle here is going to be equal to the angle here. And that is what we regard as the what? The same segment, right? Angles in the same segment are equal. All right. That's the very first theorem. So it's important to take note of this, that angles in the same segment, that they are what? Equal. So your responsibility at every point in time is to always look out for that line, that chord. Because once there is a chord, you now check, are they in the same segments? Because the chord will divide the line into two segments. And it's very important to, at every point in time, pay attention to those segments. So once you pay attention to that segment, your answer is right there before you. All right, let's proceed. The second theorem, just for a little iteration again on this, so that when we start solving problems on this, it will make more sense, right? Always observe any line that runs through from this point to that point is where you regard as the chord. And once there is a chord, check whether the angle, the angles formed are coming from the same chord. If they are coming and they are in the same segment, that is the alternate segment theorem. All right. So I believe that it makes sense now. Um, I can proceed to this. Okay, I even give more examples of what the diagram may look like. Sometimes, actually, one thing they will do is that in your questions, they will not show you that line. You'll see something that looks like a bow tie, right? For some of you that wore those bow tie, I think back then I used to wear bow tie as well, right? So it looks like a bow tie. So one key thing about this theorem is that they actually remove that very line here. That chord will not be indicated. You are not going to see that chord per se, right? The chord will be missing, but that doesn't mean that there's no chord there. So it is now your responsibility to check out for the position where the chord is, right? So now for this very diagram I drew here, you could see that the chord is missing. And the fact that the chord is missing doesn't necessarily mean that there is no, it doesn't mean that there is no chord right here. So I can introduce my chord by just drawing a line from here through here, and you can see that a chord has been formed, and I can apply the same segment theorem. So angles in the same segment are equal. That is theory number one. I also went ahead to also give you more, inverting it for you to see that, yeah, it can also be this way, right? That way. So you have an angle here, you also have an angle here. Now, this entails something. This is a chord right here, and I can as well introduce another chord right here. That's what I want you to see. Another chord can as well come through this place. This is another chord, right? So which means that this angle here, are you seeing it now? This is a chord. This chord forms an angle here, right? That same chord forms an angle here. So which tells you that the angle here will be equal to the angle here. Now, if I'm making use of this particular yellow chord, if this is the chord I'm making use of, this chord forms an angle here, which means it rotates from here through to this place. And this same chord will make an angle here from this place to this place to tell you that they are both equal, right? So in any way the chord comes to, always know that angles in the same segment, that they will be what? Equal. All right. That said, that is your theorem. Theorem number what? Theorem number one. Right. So let's proceed and move over to what? Theorem number two. Quite interesting. I love this topic because it's once you remember the theorem, you are good to go. Now, this one says that angles in a semicircle is 90 degrees. And now, one key thing I want you to pay attention to, for it to be 90 degrees, the chord at this point in time is going to be a diameter. There will be a line that demarcates the circle into two equal parts. And that's why we call it a semicircle, right? This is a semicircle, this is a semicircle up there. So that the angle in a semicircle is 90 degrees, right? That is exactly what theorem 2 is trying to tell us. All right. That said, observe this. You have a line running through. This is your diameter. So once there's a diameter dividing the circle into two equal parts, the angle in the semicircle is going to be 90 degrees. Look at this. This chord is forming an angle. Remember, an angle is formed when two lines meet. This line goes through and meets this guy here. This one runs through and meets this guy here as well. So you have an angle here, which is what? 90 degrees. Okay. So the same process here. This angle runs through to this edge. This one runs through. You have also what? A 90 degrees. So angle in a semicircle is equal to what? 90 degrees. So, but remember that that angle must be formed from the chord. Here is the chord here, one of the edge of the chord, the other edge of the chord. This symbol here simply means that it is what? It is 90 degrees. I hope all of these things are making sense because they are quite interesting if you really, really pay attention to the theorems. And there is no question, I promise you, that you can't solve as long as circles are involved, right? There's no question you will not be able to answer. Okay, now, yeah, you have a question?
Uh, answer, you
Okay.
call the this thing, the line that divided the segment a chord. I thought
No,
it will be a
okay.
diameter because it is now in
Yeah,
the center. It's now at the center.
yeah, yeah. Not the main thing is that any line that runs through from the edge of a circle, from one point of the circumference to another point of a circumference, is called the chord, right? So
Yeah.
diameter is a type of chord. You get the point now. But not
All right.
all chords are diameter, but all diameters are chord. For the
All
fact that you
right.
move from one point of the circumference to the edge of the other circumference means you're a chord. But when that chord now divides it into two, that kind of chord is now what we call a diameter. Does it make sense now?
All right. Thank you.
Yeah, beautiful. Okay, that said, a chord or a diameter, I can be interchanging them, all right? So now, let's call it diameter. So when you have that diameter, it forms an angle of 90 degrees. So angle in a semicircle is 90 degrees, right? So it's important to start getting all questions you can get on circle theorem as much as possible. With these theorems, we can tackle all the questions at a go, right? This is theorem number 2. Now, let's look at theorem number 3 at this point. The theorem number 3, I hope you understood your theorem number 2 and you understood your theorem number 1, right? Can I proceed? If you are following up until this point, a thumbs up, everyone. All right, beautiful. So now, theorem number 3, and I think you should be drawing those things for you to actually relate with them when we start solving problems. So it's important you have your own notes, even as while you wait for my slides. It's important you be keeping down some things because this very topic requires that you actually get your hands dirty while you learn them. All right. So let's proceed. That said. Now, theorem number 3 is the one that we call that the angle at the center is twice the angle at the circumference. If you check, the chord will always start a movement. Look at a chord here, and an angle is formed when two lines meet. So those two lines will be coming from the two edge of the chord. It runs through to the circumference of the circle, runs to the circumference of a circle. From that same chord, an angle goes to the center of the circle. Very interesting. So we now said that the angle at that center will be two times the one at the circumference. Look at the angle at the circumference. So now the one at the center will be what? Two times the one at the circumference. This is the circumference, this is the angle formed. They can interchange it. They can actually interchange it. They will tell you that the angle at the circumference is half the one at the center, isn't it? Because if one at the center is 200, it means that the one at the circumference is going to be what? 100. So in any way they say it, they are still making reference to the same thing. Does it make sense, guys? So this is what we call the what the theorem number 3, right? And angle at the center is twice the angle at the circumference. But remember, in your questions, you might not actually see this line. You might just see a question like this, and then you are confused. And remember, it's not a must; it must face upwards. This thing can actually rotate. It can look like this. And when you see that, don't be confused, right? It can actually rotate this way. You can see this way. This thing is brutal. Oh. Somebody should clap for this my slide. See how the whole thing is rotating. All right. So now it can look like this, right? It could face this way. Are you seeing it now? So it's not a must that it must be vertically up. So all you need to do is to what? Always check out for that place where you are going to complete what? Complete this. Always at every point in time. Check out for that point where you can complete it. If you can complete it or draw your chord right there, you are good to go. Right? I promise you, you are good to go. So always pay attention to that. That knowing that it's not a must that it must look that way. Another way it can look as well, like I said, another way it can look, it can also point downwards. So your responsibility is to always check. Just keep checking. When you check, is there a chord here? Are the angles forming from that very chord? Is it touching the circumference? Is there an angle formed at the center? Then once you check and that happens, you remember your rule that the angle at the center is always twice the angle at the circumference. All right, so now what am I trying to say? I'm simply saying, I'm simply saying that there's also tendencies that we could have, the angle facing this way, right? It's not a must, it can be this way. Okay, I've turned the other way around. So let me rotate to the other side of it. So let's rotate this way. So it could actually be pointing at this way. You can have it pointing this way, right? And when it is pointing that way, all we need to do is to check out for what? Our chord. So you can actually draw your chord from this point right here. Then you take it to this point. Sorry, I think it's entirely off here, but it works here. So now that's your chord. At every point in time, check out for that chord. It should run through from here to the edge of the circle. That's a chord right here. So the angle at the center here is going to be twice the angle at the circumference. So whatever position it is, whether it is positioned this way, don't keep your head that, oh, this thing is too slanted. How will I go about it? Always remember that in any way it comes, our responsibility is to do what? Is to check out for what? Where the chord is formed. Is that okay, guys? Okay, let's proceed. Now, the next theorem is theorem number what? Theorem number, I've done theorem number 3. Let's look at theorem number 4. Now, the theorem number 4 is quite interesting and it's quite easy. And that theorem simply says that um, the sum of opposite angles in the cyclic world is add up to 180. The opposite angles in the cyclic quadrilateral will add up to 180. What that simply means is that look at this side, they are opposite. They are facing each other. And because they are facing each other, they add up to 180. So, but remember, opposite angles in a cyclic chord. This line, cyclic quadrilateral. Remember, a quadrilateral is a shape that has 4 sides. Now, for it to be possible, it must be cyclic. And cyclic means that the edges of that place, of the angle of the shape, will be touching the circle. Please, if they are not touching the circle, don't apply that theorem. It is wrong. The only condition upon which the opposite angles are going to be equal is that the 4 sides are touching the edge of are touching the circle. For example, you could have situations whereby you have a circle this way, and then you have something this way. Please don't be deceived. If you have something like this, let's say this one is here, this one is here, and then you have something like this. Okay, I think they are still touching. Let me model a situation whereby the 4 edges are not touching. One, two, three, four. 1, 2, 3, 4. Okay, so let's have this. 1, 2, 3, 4. You can see that there's an angle here, there's an angle here, there's one here. But you cannot use that theorem here. Why can't you do that? Because there is it's not touching. They are not touching actually. They are not touching the circumference of the circle. So for us to assume or for us to take up this theorem, then the 4 sides of that shape must be touching the 4 angles, like must be touching the circumference of the circle. So A plus B will give us 180, and C plus D is going to give us 180 as well. So that's that the opposite angles in a cyclic chord add up to 180 degrees. All right, that said, the next theorem we have is the tangent, right? So what is a tangent? The tangent is simply a line that kisses your circle, right? It just touches it a bit. You can see that just a little bit. That's what my teacher taught me back in the days, that a tangent is a line that just kisses the circle, just a particular point on it, right? So that's your tangent touching the circle somewhere there, right? Just a glip on it, right? So always take note of that. For us to apply this rule, for us to apply that rule, it must at every point in time. I like you saying that so you cannot forget it the way I will not forget that the tangent just runs through and then touches your circle at a point, kisses it at a point, just a particular, just a particular point there, right? Good. So anytime you want to forget, just remember what I said. Now there's this line running through, and then there's a particular point, just touches it a bit, bam, right? And then there's another line from the radius of the line. There's a radius running through down to that point where the line kisses the circle. Bam. Are you seeing it now? So that said, we say that a tangent will meet a radius at 90 degrees. So there are 2 conditions. There should be a tangent to the circle, and there should be a radius, a line running through from the what? From the center of the circle down to the tangent. And remember, as always, it's not a must that they will face this way. Sometimes it can actually go the other way around. It mustn't be a must that if you don't see them aligned as a straight line, then you are confused. So remember that it could come this way. You could have something like this, right? It is still the same thing. Look at the tangent, look at the radius, because the radius is any line that runs from the center of the circle to any point on the circumference. Remember, this is also your radius. It can run through from the center. This is a radius right here. This is also a radius from the center to this point. All of these things are radius. But the only thing we know is that there should be a tangent. If there's no tangent, then we cannot apply this variable. We cannot say that they meet at 90 degrees. And you can also see that for yourself, right? They form an angle what? 90 degrees. You could see that with your own eyes, that they actually form 90 degrees. So that's it. This is the line, this is a radius, this is your point, that's a tangent. It can come in any way, this way or the other way, right there. All right, so that said, that's your theorem number 5. Now, the next theorem I want to talk about, don't worry, we're going to solve problems on this. So you see how everything ties together. You see how everything works. You see how we are going to bring everything together just that way. All right. So that said, um, we have a line running through. Okay, I've done this theorem number 5. Let's look at the theorem number 6. Now, tangents from the same point are equal in length. The tangents from the same point are equal in length. I go again. Tangents from the same point are equal in length. So now you have a tangent. They are from the same point. This is the same point right here. So like I said, the tangent just touches the line a bit. The tangent does what? Touches the line a bit. So when they are coming from the same point, they are equal in length, right? So that's why I have this line here, that here is equal to here. So sometimes you're going to see this kind of shape. And when you see this kind of shape, remember, since they are coming from the same point, they are going to be what? Equal in length. They should and will be equal in length once ever you see that very point right here. Are you there now? So tangent from the same point are equal in length. So this line is equal to this line. Automatically, we can have a line that runs through the center this way. And if there's a line that runs through the center this way, it means that the angle here will be equal to the angle here. Does it make sense now? So this is your what? The theorem number 6. All of these theorems, they have a name. But for me, I prefer to understand what they are and not even the name. So that means that when I have a tangent from the same point, I know that they are equal in length. And with that, I know there's an angle here and the angle here is going to be equal. If you check your past questions, you're still going to see questions along this line that has to do with all of these things you are seeing right here. Does that make sense, guys? A thumbs up if you're still following. All right, beautiful, beautiful. So that's your theorem number 6. And I think it's important that each and every one of us writing this theorem down is going to help you to keep in touch, right? All right. So let's proceed. Okay. Yeah, what's happening? What's that spark? Please, I'm coming. There's a problem. What's that spark about? Okay, so that is your theorem number 6, right? So take note of that. Now, the next theorem we need to talk about is your theorem number. Okay, I also gave something. I gave a reference. Yeah, the same thing I was saying, that here and here they are equal, right? So that line TQ, this is your TQ or TP, that the line TQ, that's the entire line, TQ equal to, no, not TQ, should be TP equal to QP. Yeah, that's what I wanted to say. This is QP, right? Equal to 2P. And then you have this angle A plus A is going to give us angle P, because this angle here is equal to this angle here. So when you add them all together, it gives you angle P, right? That's your theorem number 6, just trying to make reference to that. Now, the last one I'm going to speak about is your alternate segment theorem. Alternate segment theorem. Alternate angles or angles in the alternate segment are equal. Angles in the alternate segment. Remember, this is a chord, right? But this thing is going to work with two things. There's going to be a chord and there's going to be what? A tangent. So you must see a tangent and a chord for you to apply this very theorem, right? Look at this. You have a chord, and the chord is forming an angle with a tangent. Now, that same chord is now forming an angle to the opposite side, the other segment. Remember, this is a chord, this is the minor segment. That same chord runs through to form an angle here from the two edges of this chord. Observe it. There's a line here. So they run through to form this angle. So the angle in the alternate segments are equal. This angle is in the major segment, this one is in the minor segment. And not just in the minor segment, there is a tangent that forms an angle with that very guy. That is what we say that the alternate, we call it the alternate segment theory. And the angles in the alternate segment that they are equal, right? The diagram can come in different ways. Okay, I also showed you something else. Like this is this one, and then look at this one. This one, the angle was formed right here with this. But if you observe, you will see that there's an angle here as well. There are two chords here called CA. Let me name them CB and cos CD. Are you seeing that now? So this cos BD now also forms an angle with this tangent. We can actually include an angle right here. An angle can be included right here. Are you seeing it now? And then that same chord called BD will now form an angle right here. And you could see that the angle here, let's call here P, you see that they are equal in both ways. You just observe there is a tangent. Once there's a tangent, you now check for your chord. Does the chord form an angle with a tangent? If it does that same chord form an angle in the other side of the segment? If it does, then they are equal. We call them the alternate segment what theorem. Now, to clear this so as not to confuse you, this time around we are looking at chord what? Chord BC. Now, this is for chord what? For chord BC. Now, let's look at the next one, which is your what? Let's look at chord AB. So if you have chord AB, chord AB forms an angle with a tangent. Let's call this angle here angle P. I've explained this, but I just brought it out separately for you to see. Now, that said, you have another angle right here. That angle will also be your angle P. But remember something very important. Like I told you earlier, that this your alternate segment theorem is not a must to look like this. Sometimes they might be flipped. I go again. It's not a must that these guys are going to look like this, the way you are seeing it, right? Like a straight line. Sometimes it can be changed. So you need no panic. So let's assume again that we are rotating this guy this way. Let's just rotate a little bit. And when we rotate, look at what will happen at this point. So when we rotate this guy, see, it is now this way, right? So let's bring it down. This should be around 90, please, 96. Let's leave it at 90. Yeah. This is your 90. So let's move it down a bit, right? We've moved it down a bit. So observe that. The same process. You check. This is a tangent, right? Here is a tangent. And then which chord am I looking at? If I observe this chord, look at the chord I'm observing now. This chord. Let me label it. Call here chord AB now. So for chord AB, it forms a line right here. It forms an angle, I mean to say, with that tangent, right? So now this same chord AB now forms an angle from here. This is, two angles are from where two lines meet, isn't it? So we have a line running through from here to here, and then from here to here. There's an angle here. So this angle here is going to be equal to this angle here. Remember that this line, which is the chord, forms two segments. The minor segment, which is this, and the major segment, which is this. And because of this, the angle here will be equal to the angle here. I will call it the what? Alternate segment theorem. So in any way the circle is, whether straight up, whether rotated, in any way you see the circle, always remember that there should be a tangent. Once there's a tangent and a chord, it forms an angle. Then observe if the other chord forms an angle in the other side of the segment. In whichever way it comes, this is your what? Alternate segment theorem. And this is your what? Theorem number 7. All right. So now we're going to solve problems on this so you can actually apply them. So that said, I think I should give a total rundown back again. Let me give a rundown of all the theorems and then we'll get started. All right. So let's go from the beginning. I hope me guys, hope we are following and hope everything is making sense. A thumbs up if you are still with me to this point. A thumbs up if you are still with me to this point. I think Justice is in this class. Justice, hope you are following. Because I think you joined late. Hope you are following, Justice. If you are, a thumbs up. Good. Did Justice give me a thumbs up? Okay, beautiful. Well done. I can see your hands now. So let's review everything once again, please. Please pay attention. It's very important. When I start solving problems and you don't really understand all these theorems, it's going to be very difficult. Funny enough, when questions are given to you, nobody's telling you that this one is this theorem. It is you, that is the student, that will look at it and say, oh, I can apply this theorem to this very question, right? Always open your eyes to check for it. You have to understand the theorems and know when to apply them. Some questions might be easy that you just have to apply one theorem, while some of them might be complex that you have to apply up to three theorems, right? For wire questions, sometimes you can apply up to 3 to 4 theorems. But for UTME, I think at least they should keep it minimal at least 2 theorems. Sometimes it can just be one theorem. And sometimes you can still apply the knowledge of your parallel and perpendicular lines, when angles are formed in parallel and perpendicular lines. So in whichever way it is, right? I hope you are quite equipped to handle that. So let's run through whatever thing we said once again regarding your circle theorem. So the first thing I said is that you have a circle. So for a circle, any line that runs from one point of the circumference to another point of the circumference is what we call the chord, right? And that chord will divide the circle into a major segment and a minor segment. However, any chord that divides the circle into two, right? Some of the chord can divide into two. That chord is now called a diameter, which entails that all diameters are chord, but not all chords are diameter. I hope you get that very term, right? So the chord does divide the line into major and minor, but then the one that divides the circle into two is your what? Your diameter. Pay attention to that. So because the chord is central to everything we do in circle theory, every angle that will be formed will take its reference from the chord. So because of that, you can have the chord this way. Let's say this is the line. Then to form an angle, it must come from the two edges of the chord. From this point, then another point of the chord this way. So for an angle to be formed, sorry about this, for an angle to be formed, it must run through the chord. That is why the chord is central. So from that point. Also, it can point downwards, but at every point in time, it's going to come from the edges of the chord. This will come through here, and then this will come through here. So always pay attention to that. Whether the chord is at the center or whether the chord is at any point on the circle, for angle to be formed in a circle, it must run through the edges of the chord. That said, I spoke about the theorem number 2, and I said that for this one, that angles in the same segment are equal. It looks more like a bow tie. So this is your chord, like I said. This is the chord right here. An angle runs from this edge, you have this line. From this edge, you have this line. It forms an angle. The same chord, there's a line. There's another angle here. So if you check, they're in the same segment. This is your minor segment. This is your major segment. And the two angles are in the same segment. And they are running through from the same chord. Assuming that the angles are not coming through from the same chord, you cannot say that the angles are equal. So that's when we say that angles in the same segment are equal. And this is your theorem number 1. All right. So that said, I gave similar examples that you can actually point downwards. Whatever case it is, always look out for that bow tie and solve the questions accordingly. I gave other examples. That's what you have right here. Then another example you have right here. So when we start solving questions, I'm recapping these things again for you to store those theorems in your head and understand how the principle and the mechanism behind each theorem. So the next one has to do with a chord, and that chord is a diameter. If you check, this is a diameter. The angle is running from what? From this point to the circle here, from this point to the circumference here. And we'll say that angle in a semicircle is 90 what? Is 90 degrees. You can see the 90 degrees right here. So there's an angle here, and that is what? 90 degrees. At every point in time, it moves from the chord and it gives you a 90 degrees. Now, the next theorem is your theorem number 3, where we said that angle at the center is actually twice the angle at the circumference. Observe this. In this, there's no line here, isn't it? There's no line, but there should always be a chord. That angle was formed because there's a chord that is running through. And check, through this chord, this angle was formed. Through this edge, so they came together and this angle was formed. Also, through this chord, an angle was formed at the center. So the chord is giving birth to two angles, one at the circumference and one at the center. And we said that these two angles given birth by this same chord has this relationship. That angle at the center is twice the angle at the circumference. That said, um, like I said, always remember that sometimes the question will not come with this line and it can take any direction at all. Now, the next one is this. We'll have this particular theorem, theorem number 4, and I said it has to do with what? That the opposite angles in a cyclic quadrilateral add up to 180. Remember that a chord has 4 sides, 1, 2, 3, 4. But for us to apply this rule, the each side of that shape should be touching the circle. They should be touching, right? Because look at this example. They are not touching. We cannot apply that principle right here. But once they are touching, it means that C and D will add up to 180. B and A will as well add up to 180. Now, the next fascinating theorem right here is the what? That a tangent will meet a radius at what? At 90 degrees. And I said something very important. Look at the tangent. Look at the line coming from the center of the circle. Remember, your radius is any line that you draw from the center of the circle to any point on the circumference. That is what we regard as your radius. So with this theorem, I think we are good to go. Now, the next one is that radius from the same point are equal in length. Look at the point where that tangent is coming from. The tangent runs through and kisses the line, the circle right here. This is your Q here. That same tangent runs through here. That is T. So since they're coming from the same point, we'll have that line QP, right? This should be QP, please. Line QP is equal to what? Line TP. And that's why we have this line here indicating that they are equal. And you can run a parallel line that bisect that angle. So these two angles are equal. So that angle P will be theta 1 plus theta 1 right here. All right. So I went ahead to actually give more detailed example on this. You have your QP equal to TP, right? And that is the basis of everything. Then finally, we'll have the alternate segment theorem. That one has to do with two things. There must be a tangent and there must be a chord. So look at this chord. The chord forms an angle with a tangent, but the angle it forms is in the minor segment, right? Look at it. This is the minor, this is the major. There's an angle formed between that very line, the chord, and the tangent. Also, that same chord went ahead to form an angle at the other point of the circle, the other point of the circumference it runs through, and that angle is in the other segment. So therefore, they have the same value because angles in the same segment are equal. I use another example. It might not be called this very chord. We can make use of chord AB, right? So chord AB will have our line and there is a point right there. So in any case it is, always remember to apply your rules. Now, let's get straight to problem solving. Any question, everyone? Hope you understand the theorems and that you're ready to get your hands dirty. Give me a thumbs up. If you have you drawn these things down? Have you drawn them? Can we continue so we can solve questions right away? Anyone who is not following, please indicate. Anyone who is not following, indicate. Everybody's following, isn't it? Yeah. Okay. So let's see. Now, look at this question. I wish we can get more past question paper, right? This one says that in the diagram above, you have the diagram. This is what they drew for us. There's a circle this way, and then there was a line at the center. Then the line runs through this way, and then it runs through like this. And then angle here, let me increase it a bit. Yeah, they said it's 74 degrees. So here is your O, here is your P, and here is your Q. So they said in the diagram above, angle OPQ is what? So now in that very diagram, what is angle OPQ? Right? So for your angle OPQ, you simply have something right here. So check. The angle they're asking you for, OPQ, they're asking you about this angle. The angle running through from here, that's what they're asking you, from this place to this place. Now, this one has nothing in particular to do with those our rules, right? So it's just your basic thing that you know. And what's that basic thing you know? That angle at a point is equal to 360, isn't it? So now, it simply means that we have 74 degrees plus what? Angle OPQ is equal to 360. So that angle OPQ will be equal to what? 360 minus 74. So that OPQ, you can now calculate angle OPQ, you can now calculate and get your value, right? 360 minus 74. Are we together, guys? Are we together, guys? All right. Um, you could just check. I don't have access to past questions now, right? But I wish you could check. Um, Emmanuel, you can message Paul, ask Paul to help you with past questions, right? As many as possible. Ask Paul to help you with past questions so we can get our hands dirty. Be fast, please. Then other persons, you can now put down this theorem. If you've not drawn the theorem, do well to put it down. So as you're solving and looking at them, please put those things down. I give you like 5 minutes to do that. Get the past questions, put down your notes. So as I'm solving, you're not looking back again. You see the theories I'm applying.
Sir, I don't think Paul is online, but
You have
let
access to
me
that
use
app.
my.
There's an app he gave you guys.
I'm using my school, not the one that he's using. But I'm using my school. Let me check on my school.
Okay, anyone that has the diagrams actually. Yeah, it's taking time. Justice, are you there? I think I have. Let me use this. Let's use this. All right, I have a question here. So let's run with it. Is that okay? Don't worry. Let's run with it. Let's run with this. Yeah, this will help you. So you know that I check your past questions. Yeah. So
All
let's
right,
run with this.
I'm
Yeah.
sending some questions to your DM, sir.
Okay. Okay. So meanwhile, let's start with these ones. Okay. Then I think those ones. With this my examples, I'm picking the most difficult ones. So with these examples, I believe you now solve any other question related to that. Is that okay? Is that okay, guys? All right. So the first one, the first part says B is a point. Are you there? B is a point on the circumference of the circle. AB is a tangent. This is AB. Then you have that BOA is 72. Work out the size of angle BAO. So they are looking for this particular angle right here. They are looking for this angle. Are we together, guys? They are looking for this angle. Now, remember what I taught you when we looked at key things, right? That tangents from a point, right? That they are equal, isn't it? Are we together? Now, observe key things. Okay, before then, let's apply the other rule. This is a circle here. This is a circle here. Let's use this one instead of using tangent. This is a circle. Oh, interesting. Good. I've seen it. Makes sense. So after solving these ones, try
Okay.
and solve these ones yourself. Yeah, I've seen it. Beautiful. Though I will still pick some questions from there, but I think with this my own now, there's nothing you cannot answer because this is not this is not jump, right? This is not jump questions actually. But then if you can answer these ones, you should be able to answer your jump questions. Okay, look at this now. Remember this theorem that when you have a circle this way, I will also be showing you key things now. You have a center and you have a line. What did I tell you? That radius makes an angle of what? 90 degrees with a tangent. If you check, this is a radius, this is a tangent, and it's going to make an angle of what? 90 degrees right here. So the angle here is 90 degrees. You can now calculate this very angle, isn't it?
Yes.
You get the point now. Okay, so let's proceed. Now the next one, we have this line. Remember what I said? This is familiar, isn't it? So this is your angle at the center twice the angle at the circumference. So what we're going to do is just to include our line. Roll it up this way. Are you seeing it now? So here is 66. So this is a chord that formed this angle. The same chord is forming an angle here. So there's an angle here. So what does that imply? Angle at the center twice the angle at the circumference. So now, if you have angle at center, right? Center is equal to, here is going to be 2a, right? So if I'm looking for the up one, it's going to be 66 divided by 2, which is equivalent to
Divided by
33.
2. That's 33.
33. Beautiful. Are you seeing it now? They say give reason for your answer, but they will not ask you to give reason for your WAEC exam, just for you to know. So that's why I say if you can answer these ones, all those questions you sent, you can as well tackle them. It's not a problem, right? So let's proceed. Yeah, these are basic questions, basically. The ones you sent, I'm looking at them now, right? These are just basic questions. So work them out. Work them out after our examples. Work them out. All right. So the next process now, the next one, maybe I'll solve also like 5. Look at this one. Work out the size of angle BOC. Always take note. They are equal angle BOC. So there's a line from here, BOC, join them together from here to here. So there are times you have to join this one to here. So the angle they are looking for is the angle here. That's what they are asking you about. Are you seeing it now? But they said that angle BAC, BA, the one at the center, is only the one that has the angle. So the angle here is equal to what? 40 degrees. Remember this rule that tangents from the same point are equal. So which means I can run through from here through to this place, to the center here. Sorry, this is not too straight. So you can run a straight line, it demarcates them. The same rule I applied for you. What is happening, guys? So let me demarcate it before I put the angle. It's still going off. Maybe I should not straighten. Or let me just leave it manually. Yeah. Sorry. I'll leave it manually. Let's just draw something that is not straight. Just good. So there's an angle here. Here will be 20, and here will be also will be 20 degrees. Are we together, guys? Are we together? Now remember that there's a line here and that there's a line here, isn't it? Because I said that from the same point, tangents from the same point are equal. And because they are equal, that lines are equal. So you have there 20, right? So what's the next thing? If you observe, this is a radius, and this radius is meeting a tangent, which means that here is also 90 degrees. I don't know if I'm making sense. So you have here to be 20, here is 90. We can get the angle here. So it means that 90 plus 20, let's say plus that angle there, theta, is equal to 180. This is 110 plus theta equal 180. 180 minus 110 will give us theta. So theta is equal to what? 70 degrees. So the angle here is 70. The same thing will happen as well. Here as well will be 90. So here is going to be 70. So we add everything together, that will give us 140 degrees. That's the angle right here that they are looking for. Any question on this? Do we understand? Anybody confused? Give me a thumbs up if you're following. All right. So now it's quite interesting just applying the theorems. Okay, look at this one. They said that angle CAD, this is CAD, is 62. There's an angle here. Now, angle ADB here is 51. What can you see? You could see that we can introduce a chord right here. There's a chord here. And this chord will form an angle here. That same chord from this same point, form this one. This same point and this point will meet up and form this one. So the size to calculate size of angle ACB. ACB, which means we are looking for the total angle here. The angle we are looking for is the whole of here, ACB, this one, right? Because this will give me A, C, and B. Sorry, no, A, right? C and B. So AC and B is going to be, and that skill you need to have is knowing where the angle is, so, right? The one at the center is the one that has the angle, what you learned from your junior secondary school per se. So they are looking for this very angle right here. This is the angle we're looking for, A, C, B. But remember that the angle here is going to be 62 degrees. Again, check. What again can we see? Let me clean something here. Let's clean all of this. I've gotten this particular one. There's this chord here, and the chord here will give birth to what? With what? Give birth to 62. Now you can observe that there's another chord. This chord here, if there's a chord here, now this chord moves from here, good, moves from here, meets up, that will give me an angle. This same chord moves from here, right, here to this place. So here is going to be what? What's the angle right here? What's the angle
51,
there?
51,
That will be as well what?
51.
51. Good. Are you seeing it now? 51 degrees. So which means that angle ACB is equal to what? 51 degrees. What's the rule here? What do we call it? What's our rule? This is bow tie, the bow tie stuff. Angle in the same segment are equal. That's the reason for this very one. Now let's proceed again. Look at this one. You have an angle here. You have an angle here. Remember that this is a cyclic chord. Opposite angles of a cyclic chord are equal. So 94 plus C equal to 180. When you make C subject of formula, you have 180 minus 94. That gives the value of C. They said, find the size of angle ABC, which is this angle here, right? So what you need to do, if they are looking for that side, just add here and here 180, then subtract. So that means angle ABC plus this angle here, which is 83. is equal to 180. You subtract, then you get your answer. Then what's the reason? You see why I know why I'm rushing like this, because I know you've understood what I'm saying. So the reason is because of what? Cyclic what? Quadrilaterals, isn't it? Cyclic quadrilateral. So as many as they are, let me see whether I will see one on alternate segments. Then we can move over to your wire questions. Okay, look at this, right? So they said that here is 65. Work out the size of angle AOC. Now, this AOC is this angle here. You should know how to complete angles. AOC means here. So they are looking for this particular angle here. They're looking for, let's join it. So they're looking for this guy here. That's the AOC. Now, but for us to get that, remember something, your alternate segment theorem. Remember that the alternate segment theorem, you have a line running through like this. This one forms an angle here. And because of that, this same chord is going to form an angle here. This same chord will come to form an angle here. Are you seeing it? It forms an angle here. It forms an angle. Do you agree that here is 65 degrees? But it doesn't end here. If there is 65 degrees, observe something. This is also a chord, AC. And this AC will make an angle here with the tangent. Now, that same angle it makes with the tangent, there will also be an angle here. Like from this chord goes up, that will be equal to the angle here. And if I have this, I have that angle at the center twice the angle at the circumference. But the question now, how do we get this very angle here? How do we get the angle here? That's the question. Knowing that, let me clean again so you get what I'm saying. Let me start from the beginning for some of us that are confused. We're looking for, they say that AB is equal to BC. Are you there? AB is equal to BC, which means that the two angles here, do you know what that means? It means that this angle here is equal to the angle here. That's what it means. Just take note of that. If AB is equal to BC. But it doesn't end here. We're looking for this angle that runs through from here. We're looking for this angle here. Right. I'm coming. And if that's the case, sorry, give me 2 seconds. I'm very hungry and it's affecting my head. It's affecting my head badly. Well, then we'll keep pushing. All right, so let me go over it again so you can follow through. So what am I saying? That first of all, we can complete this from here to here. And they're asking us about this angle here, AOC. Right, because you're asking me about AOC, the next information I have is that this is a chord. That chord forms an angle here. Here is 65. And because it forms an angle here, it is expected that this same chord will form an angle right here. So I'm bringing an angle there. So what is the angle I'm bringing? I'm bringing an angle from here. And the value of the angle here, that total angle there is 65. That's what I'm saying. So here is going to be what? 65. Let me just bring it. This is 65 degrees. Good. Now, there's something I want you to remember. Remember your alternate angles. If you can remember your alternate angle, like normal alternate angle, you see that this angle here is bound to be 65 as well. The angle here and the angle here. And remember, if here is 65, remember that this is a chord. And this chord now goes ahead to make an angle here. So the value here is still 65 degrees. That said, you can now actually get the actual value you have at the center, because angle at the center twice the angle at circumference. So the angle there is going to be what? 2 times what? 65. Then you get your answer. Is it confusing? Is it confusing? Do you understand it? Justice, is it confusing? No, okay. So that's it. It's all about you understanding the process. Once you understand the process, you are good to go, right? Understand it, apply the rules. Quite interesting, I tell you. Very, very interesting. Then I'm going to look at the ones that I think I've touched all the theorems, the examples of the theorem and how it looks like. So let me look at your past paper now, your own past paper. I use this one for you to see what is possible, what is obtainable from it. And so you could see how the theories can be applied. So now, from the questions that Emmanuel sent across, um, um, let's look through them. Let's look through them. Let's look through them. Let's look through them. But I think there's something I omitted here. There's something I omitted here. Can we let's look at this question again, please? I omitted this thing they said here that AB is equal to BC. AB equal BC. This is a line here. And I think I didn't pay attention to that, which means that the angle here, please let's attend to that. The angle here will be equal to the angle here. Are we together now? The angle there will be equal to the angle there because both of them are equal. Do we understand? Now, yes, please pay attention. There's an error I did there, please. So now this is a chord. This chord forms an angle here. So here is 65. Now, this same chord will form an angle the other side. So here as well is going to be what? 65 degrees. I think this is better now. So now you have a chord. Here is 65, right? So the other side of the angle is going to be 65. So because AB is equal to AB is equal to BC, it means that this angle as well is also equal to 65 degrees. Do you agree? Do you agree now? Because of this line here. Good. Now, remember that we are looking for this center here. So what does it mean? For this big angle, this big triangle, let me bring it out. For this big triangle here. Sorry about that big error. You know, I said I'm hungry, guys. So here is B, here is C, here is A. So they said it here that AB is equal to BC. So if that means here is equal to here, that's isosceles triangle. So you have an angle here is 65. We have an angle here is 65. Then if I get this angle here, that will be what? 65 plus 65 plus B equal 180. 6 is 120. This is 130 plus B equal 180. So that B is equal to 50 degrees. Now, if I have the angle here to be 50 degrees, now remember that we're applying the angle at the center. So angle at center twice the angle at circumference. So center is equal to what? 2 times 50, which will give us 100. So the answer here should be 100, please. 100 degrees. I neglected this, and that's very bad. Do we understand the last one now? Do we understand it now?
Yes.
A thumbs up, everybody. Yeah, makes sense. Yeah, please always pay attention to that. Look at the instructions given to you before you start applying your rules. Okay, now the questions you sent across, wish I could import all, but then let's look at now those ones. There's one that has I'm seeing something like algebra in it. It's the same process. Is that okay? The one that has algebra in it is the same process. Just apply them and solve. But let me move everything. Let me send everything. Let's get our hands dirty. Let's get our hands dirty. And that's why we are here today. Let's get our hands dirty, guys. All right. I think it has entered. Let's quickly do that. I need to stop sharing my screen so that when I import it, you now see it. Thank you. So let's go back to our, because the document I'm going to send to you people is the other document. Is that okay? So after today's class, I know I'm done with circle theory. The next thing I'm going to do is questions on area of sector and the rest of them. That's the next thing I'm looking at. I need to teach you guys all of those things. The properties, area of sector, and the rest. So that's the next target, right? And then I'll teach angles in perpendicular and parallel lines and calculus. And I wish you guys all the best. Maths is the easiest to pass actually, as long as I'm concerned. Let me just pick those that are not similar. So work them out. There's one that might look a bit complex for you guys. Let me just touch one or two of them. Just one or two of them. Just one or two of them. One or two of them. All right. So done. Meanwhile, well done, bro. You did a nice job here. So now let me share my screen. I feel like writing another math jam again. I just go and write maths, just go and touch maths and physics. Because it's been long I did full blown chemistry. So I think I've been preparing alongside with you guys. So look at this one now, right? Not drawn to scale. Find angle OSN. First of all, which one is angle OSN? Trace it. OSN. So look at the angle they are looking for. We are looking for this angle here. OSN. Is that okay? Because this is O, this is S, this is N. Now, but they gave us here to be 108 degrees. What did I tell us to always check? Now, if that's the angle we are looking for, OXN, that angle is a bit off. Angle OXN, okay? But what can we see right here? You could see that there's a tangent here, right? So observe that the angle here, are we together? The angle here, this is a tangent. Sorry, not a tangent. This is a chord. Should we rotate this a bit? Well, let me rotate this a bit so that I want us to see something. Let's see if we can rotate a bit. Let's place it in a way that it makes sense to us. Better. Yep. Let's rotate it like this. Hope you can see it. A thumbs up. Let me rotate like that. There's a reason why I had to rotate. I want us to see something. Good. Let's rotate that way. The thing has left though. So when you rotate this, there's something you are going to see. There's something you will see. That the angle here, there's an angle here, isn't it? I need to reduce the size of my pen. There's an angle here. There's an angle here. Why is there an angle here? Because this is a chord, right? And that chord still goes up to form another angle right here, isn't it? So what does that tell you? What does that tell you right there? That angle N is also 108, right? But what we need is OSN, right? OXN, O, S, and N. So now, if let's draw a line this way to this place. Is it? Are you sure they're not asking us about ONS, or is it the other way around? Let me rotate back again. Let's rotate back. Let me see, but in particular. Okay, if I rotate back again, this is exactly what I'm going to have. And they said I should find OXN. I should find OXN. Okay, that's interesting as well. If we are to find OXN, well, let me think at the best possible route. So what I'm thinking about now is the methods that we're going to bring in now. That's what my head is sticking around. What are the methods? Now, that thing is 108, right? 108. Okay, good.
I have a suggestion.
Okay, go ahead.
Since you said all this angle at the point in total is 180, I give
Yes.
180 minus 108, then the answer divided by 2.
Makes sense. Makes sense. Because what we are looking for here, we are looking for this angle here. Thank you, brotherly. We are looking for this angle here and this angle here. And remember that this place will be equal to here, isn't it? Because they are radius. They are coming from the same center. Are you seeing it now? From the same center. So they are isosceles triangles. So that thing you said, we're looking at OSN. Yeah. Oh God. My head. Oh. Very simple thing there, bro. Thank you. I'm hungry. I've said this over and over again. Even that thing I was rotating, there's no need. So now, here is 180. So there's an angle here. So it simply means that A, let's call it A plus A plus 108. Or let's use angle. Let's use angle notation. ONS plus OSN plus NOX is equal to 180. But this one and this one, they are equal, right? ONS is equal to OXN, right? So we'll have two of them. So let's just call them equal to A. So it makes sense. So we'll have 2A plus NOX equal 180. Are we there? So we'll just do 180. Just as you are following. NOX will now be what? Be equal to what? A will be equal to what? A will just be 180 minus what? 108 divided by 2. And what would that give us? Well done, well done, well done, well done. 30 what?
36.
36. Well done, bro. Emmanuel, do you understand what we did there?
I didn't. I understand what you did, but the reasons why you did it, I don't understand. That's the thing, because
Oh,
they did not
okay,
indicate
look
that
at
the
it.
angle is a 300 angle.
Okay, they didn't indicate, but look at this, Look at this. You have a circle. You have a circle at the center. You know that radius will be equal anywhere. Any line you draw from the center of the circle, that radius is going to be the same all through, isn't it? Do you agree with me? Good. If you agree with me, then check this. Check this. This is a point at the center. This is a radius. This is also a radius. Or a red eye, since it's just one. This is a red eye, this is a red eye. So they are equal. The lines are equal. And if those lines are equal, it also means that the angles are equal. Just like what we did in the other example. Do you understand it now? So it now becomes 180. If here is equal to here, it means that 180 plus these two angles is 108 plus these two angles is equal to 180. So 180 minus 108 divided by 2 will now give you what each of them is because they are equal. Do you get now? All right, you got okay, good. I'm glad you understand it now. And I'm happy it was prompted by justice. Like that means you guys have understood what I'm doing. Like I like that. I like that. So now the next question I have there, that's a very good one. I'm very happy. Right. After this class, I'm going to straight up to go and eat, man. All right. So the next one, look at this one. They said, this thing is a bit blur, but let's see what we can do. They said from the diagram above, find x. Find x. Now, whenever you see that thing coming from the edge, anytime you see it coming from a point, always remember that thing I told you about this. I think that was the second to last theorem. That what tangents from the same point are equal. It simply means that you see this line and this line that they are equal. That's what it means. Is that okay? They are equal. Now, the next thing I'm going to look at is that we have a chord. We have a chord right here. This is a chord. Are we there now? This is a chord, right? But then before then, yes, this is a chord. And that chord is dividing the circle into two, isn't it? It's dividing the chord into two, isn't it? Good. Now, if it is dividing the circle into two, it means that, remember that angle in the semicircle is equal to 90 degrees. So now, look at it. It forms an angle. That chord forms an angle here. It forms an angle here. So it means that here, the angle here, from here to here, is a 90 degrees. Do we agree? Someone, do you agree? Good. If it is a 90 degrees, good. We can now get this angle here. Why am I stressing myself to get this angle here? Do you believe that this angle here is x? Why is it x? You have a tangent. You have a chord. And anytime a tangent meets a chord, you have an angle there. And this angle, this same chord, is what forms this angle here. And remember our alternate segment theory. This place is also equal to this place. Do we agree, guys? Makes sense. Makes sense. So if I'm to work this thing out in steps, we have that angle because you are doing WAEC now. You do it's jam. That's why I'm just doing it that way because it's jam. Nobody's looking at your step. Angle, this is R. RTS is equal to what? 90 degrees. Why? Angle in a semicircle equal 90, isn't it? Equal 90 degrees. Then the next thing I want to say is that angle here is angle RTS is equal to, this is angle T, arrow, what will I call this now? This very angle here. Let's call it T arrow. Let's call here X actually. Is equal to angle arrow T. I don't know the total of that line there. Let's call it U. What's this one now? Alternate segment theory. I'm going to alternate segment, which means we are safe to say that here is what? Here is X. And we're also safe to say that this place is 90. So we've done our work, right? So if we are to do our work here, it simply means that I have 90 plus 25 plus X equal 180. 90 plus 20 will give us 100, 110, 125, right? Huh?
150.
115, yeah. So 115 plus X equal 180. So that X is equal to what? 180 minus 115. So you can simplify that and get your answer. What's the answer?
65 degrees.
65 degrees. You can see that 65 is right here. All right. So the next theorem right here. Okay, look at this one. Not drawn to scale. In the diagram, blah, 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 blah. Blah, 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 blah. Find Q and R. So we're looking for Q and R. So look at what we're looking for. Q and R. We're looking for this angle right here. That's the angle we're looking for. All right. So now, what is the information that we have? Look at it and let's see the information we have to actually get our Q and R. All right. So now, the first thing we have to check. Now, observe something very important. That's here. This is what? This is a chord, isn't it? This is a chord, right? And that chord, let me see the other information they give us. They said that in the diagram, triangle M and the symmetric cable, MNR is a straight line, good, and MRN is equal to 41, and this one is equal to 144. Do you agree? If this line is a straight line, do you agree that the angle here, P, will be what? 141 plus P is equal to 180. This one is coming from your junior secondary school. Angle in a straight line. Beautiful. I see the thumbs up. I see the thumbs up. Now, what is the next thing I'm going to do? We're going to do 180 minus what? 141. 180 minus 141. That will give us 39. So it means that here, P is equal 39. Now, we can now get this angle here. I can get this place. And that place is going to be what? 41. It's going to be what? 41. So let me use a better biro. Will be what? 41 plus, what am I writing, brethren? It's going to be what? 41 plus 39. Let's say plus angle MRN. Let's call it N is equal to 180. So 39 plus 41, 80. So 180 minus 80 will give us 100. So that means that here is 100. Are we together? Do we agree? So now who can now tell me what this line is going to be? It's going to be 80 now, because it's also angle on a straight line. They didn't give you options for this one. Do we agree, guys? Everybody? Emmanuel, I think you're not following. Do you agree?
So I'm following, just like I'm a little bit trying to, to link the dots. So that's it. But I'm following.
You're a little bit what?
I'm linking the dots. That's why.
Okay, let's go again. Let's go again. Now, you need the foundation here. Angle in a straight line is what?
180.
180, right? If angle in a straight line is 180, observe this place. Let's go again. Here is a straight line. Now, look at it this way. If you have a line like this, you have a line like this. You have an angle here. You have an angle here. You have A, you have B. A plus B is equal to 180. So observe what we have here. You can see that it's also similar to what we have on the screen. You have an angle running through this way. From here to here is 141. So now what will this place be? Emmanuel, what
That
would
is
that place be?
why 180 minus 141
141, which will give us what? 39.
plus 9.
Do you
Yes.
agree now? Now, what again can you
Yes.
see? You can see a triangle that is like this. You can see a big triangle like this. Here is 41. Here is 39. You can
Plus
get this
9.
place, isn't it? Isn't it?
Yes.
Sum
Yes.
of angle in a triangle. Good. So what we
Which is
did, we
equal to
added
180.
everything, which is equal to 180. And after solving that value, we had that the angle here is 100 degrees. Now, here is 100. Let me just make this thing very big so you can see the 100. Here is 100. Now, what can you observe again? This is another angle. Let's call here M. So what can you observe? Another thing again. You still have the same thing. You still have the same line. You still have line
Yes.
here. Angle in a straight line. Are you seeing it now? You still have a line here. So you have here
Yes.
and you have here. So angle in a straight line is what? 180. So 180 minus that place will give us 80. So our angle is what? 80 degrees. Does it make sense?
Yes.
Beautiful.
Hmm.
Look at this one. Right? They say we should find OZ. Find OZ. Where is OZ again? Okay. OZ is the radius now. So they are looking for this line from here down here. That's what they're asking us to find. Are you seeing it now? That's your OZ. Now, if you have that here is X, here is 5. Now, okay, let's go again. Are we following, guys? That thing is that thing 5 and X? Okay, yeah, it is. I've seen the question now. Is YX is 8, right? The distance from, are we following? Distance from here to here is 8. That's actually a chord. Now, that same chord, you have, this is a radius. Do you agree? From here to here is a radius. Do you agree? This is a
Yes.
radius. Good. And that radius is what? Is 5. So the radius
5 p.m.
is equal to 5 cm. Now, do you also agree that this should also be a radius?
Yes.
Justice, are you here? That OZ as well should be a radius. Now, they say we should find it in the diagram above, we should find OZ. Okay, so but then how do we simplify further? I'm going to apply our Pythagoras theorem. I think we need our Pythagoras theorem here. But before then, observe something. That this chord, but let's go like this. Let me start from the center. Let's start from center. Now, if you have this line, this perpendicular line running through, dividing from here, you know that here will be 4 centimeter and here will be 4 centimeter. If they say that the length is 8, do you agree? Do we agree? Nobody's talking. Okay, good. So now, if we agree, remember that that means you have a right angle triangle where here is 4 centimeter, here is 5 centimeter, then here is X. So now you have here facing this side. So now we can use our Pythagoras theorem. Do we get the point? Do we get a point? So that place is our X. Now, if that point is our X, so somebody should use our Pythagoras theorem. It simply means that X now, are we following?
Yes.
Pythagoras theorem is going to be that X squared will be equal to 5 squared
5
plus 4
p.m.
squared.
Yeah.
Sorry, minus 4 squared, because I'm looking for the other side, not hypotenuse. So this is equal to what? 25 squared minus 16 squared. So x squared is equal to 9, right? So that x is equal to what? 3. So now we'll have that this portion. Are we there, guys? Sorry, my work is a bit
Yes.
scattered because I believe you guys are following. So here, from here to here, we've calculated that place to be what? This is our 3 what? Centimeter.
This here.
Are we there? Mhm.
Yes.
Now, hope you know that OZ is a radius.
Yes.
Good. Now, this OZ from here to here is a radius, like I said earlier. Now, but if you check, we have that. What do they have to find OZ? You know that OZ is 5, right? So from here to here, OZ is going to be 5, which is our radius, like I said. Now, is there another place they call? Is there small letter OZ there?
No, there's no small letter OZ. No.
Hmm. There's a problem with this question. If they are looking for OZ, then it should be 5. But if they are looking for, unless they are asking us of these smaller parts, if they're asking us of this place, from this place to this place, unless there's a smaller Z there, unless they're asking for that place. But for me, I think that the 5 is there already. Do you get? So there's a problem with that particular question. There's a problem with that particular question. If they're asking of OZ, OZ is the radius now.
Yes.
OZ is the radius. So let me go to the next place. Now this one is simple, right? So what are they asking you for? Just know that this is x plus y and x. This 2 is going to sum up to 180, right? So let's do it.
Yes.
X plus y is equal to 180. So that means that 2x plus y is equal to 180. That's the equation 1. Now, equation 2 is going to be what? This means you're going to solve simultaneous equation. X plus 2y minus, 2y minus 30 plus x equal 180. So now this means that 2y plus x is equal to 180 plus 30. So that entails that you have that 2x plus y equal 180. Then this is you now put it that x plus 2y is equal to 210. Equation 1, equation 2. So you now solve simultaneously to get the value of x. Is that okay?
Yes.
All right. So that's how to actually simplify those variables. Okay. What's the next thing here? This one says in the diagram, 0 is the center of the circle. PQ and ROX are tangents to the circle. Find the value of m plus n. First thing first. First thing first. The same thing I told us earlier. What we're going to do here is that here, this is a semicircle. So the angle here, from here to here, is 90 degrees. Are we following? The angle there is 90 degrees. Are we together? If that place is 90, because angle in a semicircle is equal to 90 degrees. Now, the next thing we need to do, they say we should do what? Find the value of m plus n. Now, look at this place. You have a line here. Look at this line here. This is a chord. This is a line. This is a chord. And that chord forms an angle here, which means this same chord now, which is this chord here, will go like this. Goes like this, point here, and goes like, wait, I have an angle here. Okay, let's start with n. This is called n. So you have an n here. So that n runs through, form an angle. That same one goes through here, form an angle. It means that the angle here as well is n. Are we there? Angle there is n. Then the next one, you have m running through from here. M is running from here to here. That same m forms an angle here. So you have an angle here to be n, to be m. Do we agree? Do we agree? Do we agree? What's the rule? Who will tell me the rule I used there? What's the theorem I used? What's the
Theory
theory? What's the name?
one, one.
No, no,
The angle in the segments
no.
are equal.
Alternate segment theorem, not first angle. This one is the last one. Alternate segment. The other one says angle in the same segment. The rule number one is same segment. This one is alternate segment. Is that okay?
All right.
Yeah, alternate segment. So now they said we should what? Find the value of m and n together. So what does it mean? We have that sum of angle in the triangle here is 90 degrees because this is a chord, a diameter. And I said that for your diameter, the theorem I said is that when you have that semicircle, angle in a semicircle equal to 90 degrees. So therefore, I'm going to have that m plus n plus 90, total angle in the triangle, sum of angle in the triangle is equal to 180. So if I put these two together, it means that m plus n altogether is equal to what? 180 minus 90. And that will give us 90. Does it make sense? So that means our answer here is going to be what? 90. Any confusion? Okay, no confusion. Thank you. Justice, do you understand it? Justice, you give me a thumbs down. Is it thumbs down that you don't have question or you understand?
Sir, please come again. My father distracted me.
Okay, that's fine. So look at what I said. Look at this. Anytime you have a chord, right? I told us that anytime we have a chord, and that chord is running through the center like this, you have a chord this way. One of the theorems says that angle in a semicircle is 90 degrees. So what does that imply? It means that that angle here, that the angle here is 90 degrees because this is a semicircle here. This is a chord here, and that chord is a diameter. So any angle formed by a diameter is 90 degrees. So when the diameter forms an angle, here is the line coming through from the diameter, and that line coming through from the diameter is going to form an angle of 90 degrees. So we agree that here is 90 degrees based on the sum of angle in a what? Sum of angle in a semicircle. Now the next one is, look at this. This is a tangent. Now this is a chord. You have a chord here, and that chord is forming an angle, and that angle they wrote here is m. Now this same chord now will now form an angle. This is a line. This is the line. So it means that here as well is m. Alternate segment theorem. Look at another chord. This is another chord here. Here is a chord running through here. This is a chord here. There's an angle here, n. That same chord forms an angle here. And that angle forms here is your n. So therefore, total angle in a semicircle will now be what? You now have a triangle that looks like this. We say that here is 90. Here is n. Here is m. And they say we should find the sum of m plus n. So that means that m plus n plus 90 is equal to 180. But they want this answer together. So it means that m plus n, move this one to this side, that m plus n will be equal to 180 minus 90. And that will give us 90. Does that make sense now, Justice? All right, thank you. Now this is the same thing. Always check if their edges are touching. All the edges are touching, just solve them, right? This one plus this one will give you 180, right? This one plus this one will give you 180. So you now solve them simultaneously. Is that okay? This is cyclic chord. This and this 180. This and this 180. You now solve. Be careful, then solve them simultaneously. Now they said calculate angle PQR, angle RPQ, and angle PRQ. All right, coordinate of 2 points P and Q in a planar. Okay, that one is easy. All right, so look at what you are going to do right here. This has to do with ratio PRSQ. Is this in a JAM question? This particular one?
I don't think it's a exam question, because I included
Yeah.
both WAEC and exam
Yes.
question. I also
Okay,
asked
because
that
this one
question.
requires resolving steps, and that's a lot, right? So let's focus on questions that has to do with you guys. So this one is very tiny, but it's the same principle. I'm seeing that what I'm going to apply here should be alternate theory, alternate segments. Immediately I saw this tangent here, and I'm seeing something like this. Are you seeing it now? And I'm seeing a line like this. It means I'm going to apply alternate. Just that the question is not clear. So observe something, please. This thing and this thing they gave you here is simply telling you that the angle here are we together, and the angle here is going to be equal. Are we together now? So that very line they gave us here should signal that to us, right? So this 64 here means that here is going to be 64. Then you can now find these two angles. I think it's similar to that one I saw before in my own question paper. Do you understand what I'm saying? Yeah. So that's it. So let me zoom in so you can see what I'm saying. I'm going to apply. Let's anything. Okay, they say we should do what? Find the angle marked T. I can't even see the place they marked T, right? But what I'm trying to say is that what that thing will entail, if you check it from your own end, it entails that this angle here will be equal to the angle here, right? And because of this line they marked here, right? This line they marked, it simply means that here and here are going to be the same angle. So when you have one of them, let's say I have here 64, you can undo 180 minus 64 divided by 2. The value you get will be 1 for here, 1 for here. Are we together? Good. So please get your hands dirty on that circle theorem, right? The next time I'm going to look at in our next class, that should be next week. I will look at things around sector, segment, area of a segment, and the rest of them, right? And then parallel perpendicular lines, because the other question that you sent, Emmanuel, but those ones has to do with segments and finding the area of a sector. Is that okay? Is that okay?
Yes.
Okay, so all the best, guys. Always ensure you are practicing, always ensure you are solving. So everything revolves around getting the key concept of everything. And forgive me, I couldn't upload the physics yesterday, but eventually I'm going to upload the physics class after now, right? I'm going to upload it after now. So all the best, guys, and I wish you all the best and keep going, keep practicing, keep doing as much as you can, right? And I hope you can solve any question on circle theorem now. Give me a thumbs up if you know you've been equipped to solve all kinds of questions on circle theorem. And before now, how many of you find circle theorem confusing before now?
Me, me.
Justice, how about you?
Anything circle. You stop me.
But now you understand the circle theory, isn't it?
Yes.
It's now simpler than you thought it was before now. Yeah. So personally, even me, when I was in school, secondary, I circle theorem back then was guesswork, right? But why it was like that is because in the textbook, some of the textbook they wrote, God of Miracle, you have example. If you go to comprehensive maths, the theory they have there is up to 15 or more than 20, and you're asking yourself, how will you actually remember those theorems? Check your comprehensive maths textbook. You have about 21 theorems. I can remember back then a lot of theorems, but then all those theorems just tied together into 7 key theorems, like I showed you. All those expansion. Once you get that 7 theorems, and then have a little knowledge about isosceles triangles, right? When an angle is isosceles, and that is all. All the question revolves around these key theorems. I'm going to see that it's quite direct. Just that some of our textbook they didn't do justice to it at all. All right. So that's it, guys. I will see us on Friday. That's tomorrow. We should have our physics class tomorrow, basically, with other people tomorrow on that light. And until then, I wish us all the best. Any question? Meanwhile, let me check if I'm leaving out any other question that you sent to me, Manuel. Oh, yeah, I think we touched everything. Okay, we touched everything. Yeah, just go ahead and solve as much as you can. Right, the same process. If you have any challenge with anyone, you can just forward to my DM, okay? And then we'll handle it hands up. The one I'm leaving out is one that says calculate the length of the arc. So length of the arc, area of a segment, area of a sector. So just prepare. By next week, I'm going to handle that. And angles that has to do with in a line, parallel lines, anything that has to do with triangles that's not a circle. We're going to look at that as well. And until then, I wish us all the best. All right, guys, take care. Remember, you guys have class this evening, this afternoon. Chemistry, right?
No, today is only one subject.
Okay, only one today. Okay, interesting. Interesting. Okay, so I'll see you guys tomorrow then. All right.
All right, thank
All the
you.
best. Yeah, you're welcome. Yeah, go and solve more questions, okay?
All right.
Okay. Hello, Titi. Yeah, how you doing? So what's you are sleeping? Jump up from there, Jare. Jump up, jump up, jump up. I tell you, say me, I never sleep well. I slept around 2 o'clock and I woke up around 6. Mhm. That's the bro. I've been doing it for so many years. That's getting used to it. I just come to the class. Come online.